Welcome back to this session on data engineering. In this session, we are going to see how we can transform a CSV file to a NoSQL database. In one of the previous sessions, we have seen how we could transfer a CSV file to a SQL database. And as you know that there are many cases where the data needs to be stored in a semi-structured or unstructured format and not in a structured format, and there a NoSQL database comes to use. So in such kind of transformations, we can use Azure Data Factory to transform any file from a CSV file to a NoSQL database. So we'll see this process. So first we'll create the storage account, which is our source. We're following our normal naming convention, which I've done in the previous videos as well. We'll use a standard performance and we'll use a locally redundant storage. We'll enable hierarchical namespace. We'll have a hot tire. Rest of these things we leave as default. We'll create the storage account. The deployment is going on. Should be completed very soon. Yes, it's got deployed. So we'll create a container, and within the container, we'll have a directory where we are going to upload our CSV file, a CSV file called cars.csv, which we have used in one of our previous assignments as well. To create the container, we'll call this container as auto or automobile. And inside this container, we'll create a directory. Call this directory as cars. And inside this directory, we're going to upload the CSV file. Pick up the CSV file from the local folder where we have saved it and upload it from there. Here's the cars file. Upload it. Got uploaded. And preview this file. The preview, so it has got uploaded correctly. So now we'll go and set up the sink. The sink in this case will be a NoSQL database. So we will use Cosmos DB. Cosmos DB is one of the Azure's native NoSQL database. There are other popular NoSQL databases like MongoDB and all. But in this case, we'll use Cosmos DB because it is very well compatible with Azure. So we'll create the Cosmos DB account. We'll use this Cosmos DB for NoSQL. We'll not use MongoDB in this particular exercise. But MongoDB is also a very popular NoSQL database. Okay, we'll use the same resource group. Usually all the services in the project will be clubbed together in the same resource group. Call this Cosmos. The location will take India. Uh, we can have provision or we can have serverless. In provision, you provide a upper limit to the amount of storage and compute that Azure will provision for you, but will charge less than that if you're using less than it. But there's an upper limit to the maximum use. Whereas in case of serverless, it is completely elastic. It will expand and contract as per the specific requirement at that point of time. So there may be compute requirements that may vary minute by minute. In that case, serverless is extremely useful. We'll leave it as provisioned. Can leave it as default. Leave it as all network. These things we can keep it as locally redundant storage. Everything else is default. Rotation is successful. Create the Cosmos DB account. It's getting created. It usually takes a little more time than the data lake. It should soon create it. Taking some time. Taking quite some time. Uh, Sometimes the provisioning of the server takes time because we are using a student account. So not the or an abundant amount of server is provisioned for student, and if there is excessive workload, then it might take more time to get deployed. It also depends on the type of activity. For example, a data lake usually takes less time, but things like Cosmos DB might take more time. Okay, so it has been created now. So in the Cosmos DB, we need to go to the Data Explorer. What we need to do is, if you remember, in a relational database management system, we have a database and a table in which the data is stored. But in a non-relational database management system, you don't have a concept of a table. Instead, you have a concept of a container. So you need to create that container. Okay. However, unlike relational database management system where you need to define the structure of the table, the schema of the table, here it is a non-relational database. So the structure or the schema of the table of the container is not required. So here you can see we are going over here and we'll create a new container. And inside a container, we have a database and a container ID. It is equivalent to a database in a SQL and a table. Okay, so container is more like a table. So we can call the database as automobile and the container as cars. And there is something called a partition key. I have put a partition key as /ID. We will see what this partition key denotes. Uh, mm, so when data is stored in a NoSQL database, it is stored in a key value pair. Okay, and their partition key is an important identification of that key value pair. So we'll see that once the data gets populated, it will be easier to understand. So as of now, we'll just say okay. Now the system is slightly slow today. Maybe there are extra load on the student, the servers that are allocated for such student activities. Wait till it gets created. Let me pause this video and come back when it is created. Okay, so you can see now this is created. Now you see the database is automobile and the container is cars, which I said is equivalent to table. And if you see under items, there is nothing here. So this is where actually our data will come once the data has been transformed from the CSV file and pushed into this NoSQL database. Okay, so we'll leave this sync over here. We'll come back over here once our transformation is complete, and we can see the data is populated in the container. But now we need to create our transformation engine, which is our Azure Data Factory. We'll go to the Data Factory. If you remember that in a Data Factory, we have to create totally 5 components. We have to create 2 keys on either side. They provide access to the source and the sink. In our case, the source is the data lake and the sink is the NoSQL Cosmos DB. Last time when we did for SQL, the sync was a SQL database. This time it is a NoSQL database. Then we need the data sets, which is basically the disassembly and assembly instruction. This is the data in a lower level. Okay. And then you have the copy function, which acts as the transporter to transport the data from the NoSQL, from the CSV version to the NoSQL version. So let's create the data factory first. Use the same resource group. It has version 2. So need to configure Git now. Data factory has got deployed. We'll launch the Data Factory Studio. Launch the studio. And now in this Data Factory Studio, we are going to do the transformation. We will close this video here and we'll do the transformation in our next video. Please stay tuned.